Hello again, students. Welcome back. This is still lesson 10-3. It's part 2. Get a good look at that problem there. I'd like you to pause the video, see if you can figure it out, and I'll be back with the solution. Alright, so I'm assuming you have tried it. Let me walk you through. So I'm using some of the theorems that we proved in the previous lesson. If a chord is 72 meters long, so here's my chord, and we talked in the previous lesson about drawing convenient radii. So you'll notice I drew two radii that were kind of helpful. One that's perpendicular to my chord, because I know that will always bisect the chord. So instead of a total of 72, I've written 36 and 36. I also drew another convenient radius here to form a right triangle, and that allows me to use the Pythagorean theorem, x squared plus 36 squared equals 45 squared. And if you go through your algebra, it comes out to be 27. This is what the question is asking for. When it asks for the distance from the center of the circle, remember the distance from a point to a line always means the length of the perpendicular segment. So the answer is not this. The answer is not this. The answer is always the shortest distance, the perpendicular segment length from the point to the line. So 27 meters is the answer. Let's take a look at number 2. Let you get a good shot of that, and then you can pause your video. All right, let me find my solution to number 2. See how you did. So similar picture, I drew my chord, and because it told me the distance from the center, it's 20 feet away from the center, so I drew a perpendicular segment from the center to the chord, and I labeled that distance as 20. And I also drew a convenient radius, once again forming a right triangle. So from yesterday's work, we know that a radius perpendicular to a chord bisects it. So instead of 42, I wrote 21, 21. Another Pythagorean theorem. Be careful, the question didn't ask for the radius, the question asked for the diameter. So the answer is not 29 feet, the diameter would be double that, 58 feet. I've got one more for you. Bless me. All right, I'm going to assume you've paused it and tried it. So here's our last one for today, the solution. When we started the chapter on the first day, lesson 10.1, we talked about how if you're given the circumference of a circle, you can figure out the radius, and therefore you can also figure out the diameter. So if circumference is diameter times pi, and we're given the circumference to be 178 pi, I fill that circumference value in my formula. So 178 pi is the diameter times pi. So to solve for d, all I did was divide both sides by pi. So the diameter had to equal, when the pi's cancel, 178. If the diameter is 178, the radius is half, 89. And then on my picture, once again, I drew the chord that was in question. The distance to the chord is that perpendicular segment length of 39. Convenient radius, we now know how long it is, it's 89. I guess that's centimeters. So once again, Pythagoras to the rescue, right triangle, one missing side, Pythagorean theorem. You go through your algebra. X comes out to be 80, but again, be careful, did you answer the question? The question was, how long is this chord? 80 is only the length of x, but remember, a perpendicular radius bisects that chord. So if this is 80, this is 80, the length of that chord would be 160 centimeters. So hope you guys got something out of that. I'll be back with the next lesson soon.